Good morning and welcome to Strudel, making music with code. If you haven't done so already, head off to strudel.cc and let's get going. So Strudel is a browser-based coding environment. You don't have to install anything, you just write code here, play it, and it runs your code. So strictly speaking, it is a REPL, a read, evaluate, play loop. So it reads what you've written, it evaluates the syntax, it plays it or prints it out, and it loops around to the beginning again. You write code here, and you play it with this button here. Okay, so this $colon at the beginning introduces a new piece of code. S stands for sound. Makes no difference if you type in an S or the word sound. S is just a shortcut for sound. Everything is a function call. If you're from a coding environment, you're pretty used to this, that everything is a function call, which is why we've got brackets of it after everything. So sound is a function call, bank is a function call, deck is a function call. You call the function bank, and that is the parameter you pass to it. Okay, it's either plain text, so it's in speech marks, or it's a numerical value, or sometimes a keyword, in which case you don't have to put it in speech marks. So the sound we want to create, new piece of music. The sound we want to create is a bass drum, a hi-hat, an open hat. 2 beats to the bar. So we play that. You get bass drum, then hi-hat, bass drum, then open hat. And that is because we have chevrons here. If you take the chevrons out, just plays it sequentially. But with the chevrons in there, it plays everything inside the square brackets in sequential order, that it treats the hi-hat and the open hat as a subset of it. So it goes bass drum, hi-hat, bass drum, open hat. You can put a hi-hat in there, so it will do an extra hi-hat. You can put a hi-hat here. Put an open hat here. Put an open hat here. So it plays everything sequentially, one after each other. If you put in chevrons, it's a subset of the main set. Change that to a 4, it plays twice as fast, 4 beats to the bar. You can keep on going, you can make that 16-bit. Too quick. Let's keep it at 4. So that's the sound you want to create. And what you want to create it from is this bit here. You want to create this from this bit here. It's a bank, means a group of sounds called the TR-909, which is a drum machine. If you click over here and click on drum machines, synths, wavetables, and other bits and pieces, you see all the drum sounds that you have got. Now, some of them are not banks of sounds, these are individual sounds. So we have a hi-hat here, and we have a rim here, snare drum here. But we want to play all our sounds from a bank of sounds from the TR-909 synth. We can change that to a different synth. We can change it to a DMX, and that gives you a different set of sounds. Okay. Now the next function we have is one called dec, which is short for decay. You pass to it a numerical value, so you don't have to put in speech marks. And 0.4 is the speed of the decay. What we mean by that is the shape of the sound. If you listen to the open hat sound, it bleeds, it lingers, it resonates. Okay. If you change that to a 9, you have very little decay, so you get the full resonance of it. If you change that to a 1, a 0.1 rather, you get a fully clipped sound. There's very little decay to it. And it begins to sound more like a hi-hat. 0.4 is a middle value, 0.5 is literally a middle value. 0.4 is a nice middle value. It doesn't bleed too much into the other notes. And it provides a nice contrast to the clip sound of the bass drum and the hi-hat, which is naturally clipped anyway. Okay, so there we have a breakdown of the sound. We can put a visualization onto it. We can do another function call. Dot separates out, as in lots of programming languages, especially object-oriented programming languages, you have dot separators. Dot underscore piano roll, and it's a function call. So you put brackets there, not passing any parameters to it, no value being passed to it. What this will give us will be a piano keyboard type display of what we are doing. And that does two things. It makes us look cool and it helps us to visualize what is going on. Now, we don't have to stick with one line of code. We can copy and paste this and produce another line of code. Why do we do it that way and not just start another line of code? Well, if you make this one different, 16, TR-909 again, TR-909, we should have two different sounds playing. We don't. And we don't because it runs sequentially or it runs procedurally, in that it won't run this line of code until it is finished with this line of code. But there is nothing to stop this line of code. This line of code will just run forever. Therefore, it will never stop here and then run this one. But if we put the $:colon to signify a new sound, it'll run them both at the same time. It's not waiting for one to finish before it starts the other. They're both running at the same time. Right, what do we got? 4, 4. So if we change 1 to 2, we should be able to hear the difference. And you can hear the two rhythms mixing with each other there. We can change that, and that keeps them more in time. You've got four beats and 2 beats going on, and this fits in a bit better. So there we have it. That's enough for today's lesson. Have a play, have a mess around with it, see what you can learn. It's a version of JavaScript. You might recognize bits and pieces. It is a procedural programming language written in this way. There are lots of things to play with. Have a go at making some backbeat, and I'll join you next time for a bit more involved bit of music making.